When we left off, we were looking at this simple program that takes a chunk of memory, 12 bytes, puts D's in them, prints it out, writes it to a file, resets that memory to all A's, and then reads back the D's, the 12 D's, from the file back into memory, and closes the file, prints out mem. So it should print out, if everything works, it should just print out 12D and then 12D's again. Alright, so there's a bunch of things we can talk about here, but I want to focus on a few things. You want to be aware of all of the pound includes that you need for all of this code to work. Sure, I'm hoping that's straightforward. I want to talk about this thing. What exactly is this flag? And also you should probably have some error checking. Like, for example, once you open the file, you should probably check and make sure that the handle worked. If it didn't work, that is, you have an invalid file name, you should probably quit the program. Otherwise, it'll crash badly. Okay, so now let's take a quick look at this. What goes in here? What is this second argument to the open function? So let's go back. I'm going to go back a couple of slides to where I talked about open. We're using this one, this open call, where we pass in an int, and these are a bunch of flags that are quote-unquote ORed together. That is OR, that is a Boolean OR operation. This is different from the double bar. So notice that what we do here is we have a single line, sort of like one half of the Java Boolean OR operator. Remember, there's the ampersand for and, two lines for the OR. That's the two lines are the logical ORs. That is, they only work with true and false values on the left and right hand side. They're binary operators. If you see a single bar, that means it's a bit OR operator. What does bitwise OR operator mean? It means that each bit and you OR them together. So let's take a quick look at how flags work. So these are flags, that is, they're either 1 or 0. They're passed as a sequence of 32 flags, or 32 bits, as one chunk, and that's passed into whatever function. For in this case, we're looking at the open function. So how do we use these flags? Usually what we do is we can pound define various variables. So remember that the pound define, all it does is says wherever you see a mode 1 in a C program, replace it with this thing. In this case, it's just 1. So you can have pound defines for every bit of your 32-bit int. Let's say you're using 32 bits. So you'd have mode 2 for the second bit, which is just represented by a 1 in position in a particular bit location. It turns out mode 3, now these things might allow you, you might think that mode 1 is just 1, mode 2 is 2, mode 3 should be 3. No, it isn't. So mode 3 means the third bit from the right edge of a number is a 1, and the number that has a 1 in that position, that's the third bit, is 4. Mode 4 is 8, and you can probably see the trend here. These are all powers of 2. This is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, and so on. And when you get up to mode 32, it's 2 to the power 31, whatever that is as a decimal number you can put out here. Okay, so why do we do all of this? Because each one of these bit locations usually means something. So for example, the bit at the rightmost location of a 32-bit number, which is what this is, a 32-bit number, the bit at the rightmost location, that's quote-unquote the first location, first of 32. So this would be 1, this would be 2, 3, and so on, all the way up to 32. Or if you use the more computer science notation, you might call this bit 0, bit 1, and so on, all the way up to bit 31. Either way. Okay, I'll try to stick to this being mode 1. Why? Because I guess no special reason. So let's say we set the int value flag, or int variable flag, to mode 1. Mode 1, remember, we defined it to be the number 1. And let's say we want to do a bitwise OR, which is the single line. This is the single line that is on your keyboard. It's right above the enter key. You have to do shift and then hit the key above, press shift and hit the key above the enter key. So usually that's where it is. And on some keyboards there's a small gap in the middle of that line. On my particular keyboard I don't see a gap, but I know some keyboards have it. Okay, so this is called a bitwise OR. So how does this work? Let's say we have mode 1 and mode 5. So it turns out mode 5 is, let me just go back and look in here. Mode 5 is not 5. Mode 5 is 16. It's 2 to the power 4. Okay? So be careful with that. Mode 5 does not mean 5. If you see the first two, you might think mode 3 is just 3. No, it's 2 to the power 2 or 4. And mode 4 is 2 to the power 3. Mode 5 is 2 to the power 4, 16. And well, how is 16 represented as a binary number, which is what we're dealing with? It has a 1 in position 1, 2, 3, 4, 5. That's why it's called mode 5, because the 5th bit is set. Okay, so what happens when you OR them? You take mode 1, mode 5, OR them together. The way you do this is anywhere you see an 1 over here or here, you have a 1. If you see 2 zeros, you get a 0. If you see a 1 here or here, well, there's a 1 here, gives you a 1. Everything else, there's just zeros. So this is called a bitwise OR. You OR each bit. A 1 or a 1 is 1. 0 or 0 is 0. 0 or 1 is 1, and 0 or 0, 0. If you had two 1s, that's also a 1. That's how bitwise OR works. Okay, so there's not just bitwise ORs, there's a whole bunch of things. We'll take a look at that real quick. But this is what you can do with flags. So you can, this read and write is probably 2 bits that are set, 1 for read, 1 for write. And then you can OR it with something like create. That is, if a file doesn't exist, you can, if you use this flag create, you're saying that if it doesn't exist, create that file. Okay, so you can open files. Let me just go back up. You can open files with read-only, which means it had better exist, or else you'll get an error message. You can also open files with a read-write. That is, if it does exist, then you can open for reading, plus you can write to it also. You can also OR that flag, actually it's a bunch, probably at least 2 flags, OR it with this other flag for create, which would give you which would say, if you put this expression, this expression into here, into the open call, what you would be doing is you're saying, open a file for read and write, and create it if it's not already there. Okay, so this would mean that you'll never get an error message. You probably wouldn't have to check, unless there's something wrong with your name or something like that. Okay, so if you use this flag, you would create the file, you'd open it up for reading and for writing. If you create it, of course, there's nothing there to be read. You can only write to it, really. Okay, so that's the meaning of those flags. Now let's go back and take a look at this. How do you, if you're reading in bytes at a time, so that's what this is, these low-level reads and low-level writes. If you're reading in a sequence of bytes, how can you read in an integer or a floating point number? The answer, it sort of depends. If it was written using or write a low-level write function, yeah, sure. using read will be no problem at all. If it was, however, it was written in ASCII, that is, it's not written as a low-level binary number, you cannot really read it in one step. You cannot do things like read in instead of a pointer to an area of a chunk of memory. Instead of that, have a pointer to, let's say, an int. No, you cannot really do that. What you have to do is read in a whole sequence of bytes. You don't know how many there are. You would have to read in, so it might be a lot, and then you have to do some conversions, and that we'll talk about those string conversion functions that are available in the string library of C. So you have to wait for a little bit to see how you could read in ints or floats or doubles, things like that. How would you read it in? You have to do it in a couple of steps. You cannot read it in just one step. Okay, so that's going to be coming up later. Okay, so flags, I'm hoping everybody is somewhat comfortable with this. Do you have to know this for a test? I don't think so. No, I'm not. This is not the kind of thing that you would put on a test. I would put on a test, but it is something that's extremely useful, something that you will see, you probably understand better once you've taken the computer organization course, where you deal with, Boolean logic, things like that. Some assembly language programming really helps when you want to understand this. That said, it's really good to know. A lot of things make a lot more sense if you understand how binary arithmetic works, how to do bitwise operations. Okay, there are other low-level file I/O functions. For example, lseek. What lseek does is allow you to move around in the file X number of bytes. So you can move to the 100th byte or the 200th byte or the millionth byte. The return value of this is some offset. That is offset location measured in bytes from the start of the file. If you get a -1, that means the lseek did not work. How can it not work? Well, if the file only has, let's say, 2,000 bytes and you ask it to go 10,000 bytes forward from the start, well, yeah, it's not going to work. Okay, so here are some more bit operators. You can try this out. The best thing that you can do to test these out would be to just do these operations. You can say int x is equal to 5 or 3 and then print it out. What you should see is a 7. Okay, so this should make sense if you know how to convert 5 to a binary equivalent, convert 3 to a binary equivalent, and then you do the bitwise OR operation, which is if either one of the bits that you're ORing is a 1, you get a 1, otherwise it's a 0. If you have 2 1s, it's a 1. Okay, the similar operation for AND, well, if you AND the 5 and the 3, should give you a 1. You can also do exclusive OR. You can do the NOT operation, that is complement. And you can print this out. You can say int x is equal to NOT, or this is the tilde character, sorry, tilde 5, which is interpreted as NOT, bitwise NOT. And that will be a -6. And similar, this shift left, shift right, these are very useful for compression, things like that. We won't really see a whole lot of it, maybe a little bit coming up.